Hello, my name is Dishan Akbar. In this video lecture, I am going to discuss that how can we calculate consolidation settlement in fine soil layers under any shape of foundation. Mean you can have a square foundation, you can have a rectangular foundation, you can have circular foundation. So how can we determine the increase or induced stress uh, below a foundation, and then we will use that how to use that stress in the calculation of consolidation settlement. So we have given the statement of the question, that is, for the given soil profile you have to calculate the consolidation settlement for the clay layers. You can see here that we have two clay layers. This is the clay layer 1 and this is clay layer 2, and below this we have a rocky strata, that is incompressible strata. So for this we have been provided with the information of dry unit weight. Because this 2 meter top 2 meter, we can say that this is the depth of foundation. Df is 2 meter, and here the unit weight of the dry soil is 19 kilonewton per meter cube. And saturated unit weight from this point to this point, the saturated unit weight is given as 20, and other factors as cs swelling index is 0.05, compression index is this one, e naught is the primary or initial void ratio of the soil, and sigma dash c is 80. This is known as the pre consolidation stress. This is the maximum stress, or the stress which is maximum and has been observed by the soil prior to this state. If we are examining this site today or at this time, then we will find that how much maximum stress this soil has undergone before this time. How much maximum stress. So basically at the middle of each layer, because we have two clay layers, so at middle of each layer we will determine the sigma dash c. We can say that is sigma dash c or sigma prime c 1 and 2. So this pre-consolidation stress or pre-consolidation pressure is given as 80 kPa kilopascals for first layer, and this is equal to 200 kilopascals for second layer. And both the layers have specified properties which we need to calculate the consolidation settlement. But most important thing is that which case of consolidation will we use here. You can see here the size of foundation is written here as 10 meter by 10 meter. So it means that the foundation is of square shape, and the pressure over the foundation is q net, that is equal to 150 kilopascals. Mean this total pressure q is being applied on this foundation level at a depth of 2 meter from the ground surface. This is the ground surface, and you can see that there here is the groundwater table which is coinciding with the base of the foundation. So we will consider presence of groundwater at 2 meter depth from the ground surface. The first step that you will do here in this case is to convert this q. You can see here the unit of q, that is kilopascals. We have to convert this q in kilonewtons. To convert kPa to kilonewton mean to convert stress or pressure to force. What will we need? We will multiply this q by the area of foundation and we will find p. So simply, what will we do? We will write that P is equal to Q times the area of foundation. What is Q here? This is 150 kilonewton per meter squares. This is kilopascals times area of foundation is 10 meter times 10 meter. This meter square will be cancelled with this one, and we will get 15,000 kilonewton of force acting on the foundation. So we can say that let us say we have this type of foundation and a load of P, that is 15,000 kilonewton is being applied on this layer. So now we need the settlement in both clay layers. So basically, due to this applied load of 15,000 kilonewton, we want to determine the settlement in this clay layer of 6 meter and in this clay layer of 6 meter. And remember that we start calculating the consolidation settlement below the base of foundation, below the base level of foundation. So means we will start the first layer at this point and it will end at this point, and the second layer will start from this point to this point. So we can say that both the layers are of 6 meters each. So, what are the conditions for calculation of consolidation settlement? The first condition is that we will determine the geostatic vertical effective stress. This one, geostatic vertical effective stress. We will calculate this by using the formulae. This is a simple method. I will let you know that how to calculate. I have recorded a lecture on this that is available. I will provide you the link of the YouTube channel of my YouTube video on my channel. So, if this geostatic vertical effective stress is equal to pre-consolidation stress, then we will say that our soil is normally consolidated. So, for this consolidation, we will use this formula to calculate the consolidation settlement. But if this condition is not satisfied, then what will happen? We will check either the soil is over consolidated or not. How we check the over consolidation? This over consolidation is checked by over consolidation ratio, that is equal to sigma dash C divided by sigma dash naught. Mean pre consolidation stress divided by the geostatic vertical effective stress or effective vertical stress. If this ratio is greater than 1, so we can say that soil, our soil or clay is over consolidated. Mean it has a maximum stress in past as compared to present time. Means we will check in this example that how the past stress is more as compared to present stress. And now we will check if this sigma dash C over sigma dash or sigma prime naught is greater than 1. So what will we do? We have two cases for over consolidation case. This is case 1. We normally call it as over consolidated case 1, and this is case 2. So if this sigma dash C is greater than sigma dash naught, uh, simply it will be greater than 1, their ratio will be greater than 1, then which case will be applied, either this one or this one? For this we have to check either sum of this vertical effective stress and induced stress. This is vertical effective stress and this is induced stress. This is, you can say, simply say, this is soil stress and this is loading stress, the stress due to applied loads. So if loads are not present, then loading stress will be equal to 0. But if loads are not present, soil will have soil stresses from itself, from the structure of soil itself. So if summation of geostatic vertical stress and induced stress is less than pre-consolidation pressure, sum of both these values, we can calculate this one, we can calculate this one, and this one will be given in our question. As we can see that this is given in our cases for both soil layers. Here it is 80 and here it is 200. So, first of all, we need to calculate. So basically, we are going to use a formula. To use any formula from these three, we will need to determine the value of sigma prime naught or sigma dash naught and delta sigma prime. To calculate these values, these are the steps which we will follow. Simply, you can see here, we will find the total vertical effective stress, then we'll find pore water pressure, then vertical effective stress, then induced stress, sigma prime C or pre-consolidation stress will be given. Then we will check the case either normally consolidated, over consolidated, or over consolidated case 2. Then we will choose the formula for this one, formula number 1, for this formula number 2, and for this formula number 3. We will apply the relevant formula and we will calculate the SC in millimeters or inches depending upon the units. So first of all, the step 1, what is step 1? To calculate vertical effective stress. Simply, we want to calculate the vertical effective stress. So at which point we want to determine the vertical effective stress? Simply, this is clay layer 1, we will stop at midpoint. This is clay layer 2, we will stop at this midpoint. So for first clay layer, we will call this distance as Z1. This will be 3 meter because this whole layer is of 6 meter. From this point to the center, it will be 3 meter. And what will be Z2? You can see here that this distance in vertical direction will be 6 meter. This whole layer, first layer 6 meter, and next this is 3 meter. So Z2 will be equal to 9 meters. 6 and plus 3, 9 meter. So at the center, because we want to determine the consolidation settlement of both the clay layers, so we will determine the vertical effective stress at these both points. We will call them as subscript 1 and 2. So simply we can calculate sigma dash naught 1, that will be equal to, from this you will start from this point and will go to this point, and you will consider that what is gamma s times hs minus gamma w times hw. What is gamma unit weight of soil? Is this soil a saturated soil? Yes, because water table is here. So below this water table, the soil will be saturated. Always the soil will be saturated below the water table. So gamma saturated, for this soil we have gamma saturated as 20. This we will not use this 19 because this is unit weight of dry soil for this soil. But we are moving from this point because this point is coinciding with the base. We will move in downward direction from the base. So we'll simply write it as 20 into what is height of soil above this point, 3 meters, minus. Is there any other soil above this point? No. We have only clay 1. So minus what is gamma W? We will consider here as it as 10 for simplified calculation, but normally gamma W is taken as 9.8 or 9.81 kilonewton per meter cube into 3. The stress increase will be 30 kilopascals at first point. Now move towards second point. Sigma prime 2 is equal to gamma s hs minus gamma w hw. This is a simple formula. Now, these gammas may be multiple. Mean you may have one layer of soil, you may have two layers of soil. It depends upon the number of soil layers available. So here we can see that if we want to move, always start from the line or point which is at the base level. This is the base of foundation. So we will always move from this point for all layers. We moved from this point till the center of this layer, and then now we will move from this point to center because we want to determine the total stress at this point. How much effective stress is acting at this point? So how many layers we can see? We can see here that clay 1 and clay 2. So we will write gamma S1 H1 plus gamma S2 H2. Gamma S HS will be converted to two phases because here we can see the two layers. Minus water will be single entity, gamma WHW or HW gamma W. What is gamma S1? What is unit weight of this soil layer? The unit weight of this soil layer is saturated because this soil is below the groundwater table. It will be 20 times what is H1? 6, because whole soil layer is included in this length you can see here. Plus what is unit weight of second layer? This is 20, you can see here, times 3 meter because we have total 9 meters and we have counted this 6 meter already, and now we have remaining 3 meters here, and this 20 times 3, 20 times 6, 6 plus 3, 9 total, minus what is HW? Height of water from this point. What is height of water? We can see water here. It is at height of 9 meter from this point. We'll simply write 9 times 10. It will be 90 kilopascals. So we have moved to this step. You can skip these two steps and you can directly go to this step by using these formulae, sigma dash 1 and sigma dash 2. So remember, we have calculated these two stresses at midpoints. So we'll write in the next phase at this point that sigma dash naught 1 is equal to 30 and sigma dash naught 2 is equal to 90 kPa. Now we will move towards next thing, that is step 2. What is step 2? That is determine induced stress at mid of each layer. We will select the mid as we did in the last step. We will select the midpoints and we will determine that how much induced stress due to this applied load is at these points. This point is 1, this point is 2. Will similarly indicate Z1 and Z2. Z1 is equal to 3 meters and this will be Z2, and Z2 is equal to 9 meters. So simply we will find out, we will use 2 ratio 1 method. This 2 ratio 1 method means we will extend inclined lines from the base of foundation to that specific point. So what will be the ratio of these lines? This will be 2 ratio 1 and 2 ratio 1. Simply. So we have converted this Q into P, Q to P. When Q is equal to 150, the P was 15,000 kilonewton. When Q was 150 kPa for a foundation of 10 by 10, we had P value of 15,000. Simply, I told you that P is equal to Q times area of foundation. Q is 150 times area of foundation is 10 by 10. So it will be equal to 15,000 kilonewtons. So simply, to find delta sigma 1, delta sigma prime 1, we will write it as P by B plus Z1 into L plus Z1. What is P here? This is 15,000. And what will be B? You can see here the dimensions of smaller dimension will be B. So what is B here? 10. Plus what is Z1? 3. And L is also 10 plus Z is 3. So when we will add, it will be equal to 15,000 over 10 plus 3 is 13, 13 square. This is also 13, this is also 13. So these are 13 square. It will be 169. 15,000 over 169 will be equal to 88 point, nearly 88.8 kilo pascals. So simply we can say that delta sigma 1 prime is equal to 88.8 kilo pascals. So now we will check the case. Uh, Better that we calculate the consolidation of clay layer 1 first, then we will go with the clay layer 2. Remember the value 90 for the clay layer 2. What we have now write it as sigma prime naught 1 equal to 30 kPa. From the given data, we have calculated the value, we have known the value of sigma dash c, that was 80 kPa given. Now check which case can be applied here. What is induced stress at this point? Sorry, there is a mistake. I think yes, this is geostatic vertical stress. For geostatic vertical stress, we will include this top 2 meters because we consider that there is no foundation available when we are going to calculate the geostatic stresses, because these stresses do not need amount of loads. So simply we will add the dry layer 19 multiplied by because the unit weight of this soil is 19, this dry times 2, this will be equal to 68 kPa, and this will be 90 plus. We will add this 19 times 2. 19 times 2, this will be 118 kPa. Sorry for this, you need correction. So we will have sigma dash naught 1 equal to 68 kPa, and we will have sigma dash naught 2 equal to 118 kPa. We'll forget these 90 and 30. So this will be 68 kPa. Now compare sigma prime C and sigma naught 1. Take OCR simply. Sigma dash C over sigma dash naught. So this is pre-consolidation stress and this is present stress. Present mean at the spot, at the point, at this time, and sigma prime C is in past. So maximum stress in past is 80, and at present the stress is 68, means soil has undergone a maximum stress in past, not now. Now it's 68, but in past it was 80. So the soil has been under maximum stress in past as compared to present time. So surely it will be greater than 1. We don't need to calculate this OCR. We just want to see either the numerator value is greater than denominator or not. Yes, this is 80, this is 68, so this will be greater than 1. So we can say that this is over consolidated. Which case 1 or case 2? Which one? So for that value, we want to determine the summation. So simply we will add sigma dash naught 1 plus delta sigma. What is sigma dash naught 1? This is 68 plus what is delta sigma? This is 88.8. This is equal to 156.8 kPa. This is greater than sigma dash C because sigma dash C is only 80. So if the summation of these two values, geostatic stress and induced stress, if summation of these both stresses is greater than the pre-consolidation stress, so we can say that our soil is over consolidated, but the case 2 will be applicable. In theoretical part, I told you that if here, if sigma c is less than summation of these two values, then we will have case 2. Summation of these two is greater than sigma c, or sigma c is less than summation of these two values. This means same. So we will apply the formula for consolidation settlement of 1 SC1, that will be equal to CC H C over 1 plus E naught log of sigma dash C over sigma dash naught plus C, sorry, this is CS, CCH over 1 plus E naught log of sigma dash naught plus delta sigma dash naught over sigma dash C. We'll put the values of for clay layer 1 because we are going to calculate the settlement of this layer. So what is CS for this layer? This is 0.05. This CR is recompression or swelling index. CR and CS are same. So it's 0.05 times. What is height of first layer? This is 6 meter. Over 1 plus E naught for the layer 1 is 0.8. Log of sigma dash C is 80. Sigma dash naught is 68. Plus C, what is CC? 0.15 into height of first layer is 6 meter divided by 1 plus E naught is 0.8 log of, what is sum of these two values? We can see here 156.8 over what is sigma dash C, that is 80. When we calculate using calculator, we can calculate it as part 1 and we can calculate it as part 2. So we will calculate these parts and we will add them. We will get an answer that will be 0.9 158 meters, or if we multiply this answer by 1000, it will be 158 millimeters. So this is the consolidation settlement of clay layer 1. Now moving for the clay layer 2, for SC2, we have calculated sigma dash not 1, that was 118 kPa. That was not 90. Uh, by adding this 2 into 19 and the whole geostatic stress. What will be delta sigma 2? That will be equal to P over B plus Z2 into L plus Z2. B and L are the sizes of foundation. So what is P? This is 15,000 divided by what is B here? This is 10. And what is Z2? We found it already. That is 9 meter. And 10 plus 9. So here the stress increase below this foundation will be 41.6 kPa. Now check what is the ratio of sigma dash C. Sorry, this is sigma dash 2. So what is OCR of this soil? Remember, for clay layer 2, we are now interested in clay layer 2. We have calculated this 158 millimeter. SC1 is 158 millimeter. So OCR is sigma prime C over sigma prime naught. Sigma prime C is 200 given this one, over sigma prime naught is 118. It will be greater than 1. Surely it will be greater than 1 because this is 200 and this is 118. So this is OC. OC. Which case? 1 or 2. To check this, we have to add these two values. What is sigma prime? This is 118 plus what is value of induced stress, that is 41.6. It will be 159.6 kPa. Since the sum of these two values is less than sigma prime C, so what can we say? This is less than sigma prime C because sigma prime C is 200 kPa for soil layer 2. So we can say that this is OC case 1. Case 2 is when the sum of these stresses is greater than sigma prime C. But now this sum is lesser than sigma prime C. So we can say that this is over consolidated, confirmed here, and case 1 is confirmed here. So what is formula for over consolidation? Case 1. This is equal to CS or CR H over 1 plus E naught log of induced stress and vertical effective stress divided by vertical effective stress. I think this was 128. There's about 38, 90 plus 38 will be 128. So we can write it as 128, 169. This is a mathematical error. Sorry for that. If we make it as 128, it will be still lesser than greater than 1 because 200 is lesser greater than 128. So it will be 169. So if we put the values CS for lower layer, remember to find the values for lower layer. 0.03 times h height of layer is 6 meter times 1 plus 0.6 E naught for lower layer is 0.6 log of what is sigma dash 2, that is 128 plus delta sigma 2 is 41.6. We have calculated the summation 169.6 and sigma dash 2 is this one. So if we calculate by calculator, we will get the SC2 as 0.014 meter. So if we multiply this by 1000, it will be 14 millimeter. So simply The consolidation settlement for this clay layer 2 is 14 millimeter. So if we want to find the consolidation of whole clay between foundation and this incompressible strata, we will simply add these two settlements. Simply SC1 is equal to 158 millimeters and SC2 is equal to 14 millimeter. What will be SC in one dimension? Because we are considering the vertical dimension only, vertical direction. So it will be equal to SC1 plus SC2. That is equal to 158 plus 14. This will be equal to 170 2 millimeters, or you can say SC in 1D is equal to 17.2 centimeters, or you can say SC in one dimension is equal to 1.72 decimeters, or you can say SC in one dimension is equal to 0.172 meters. You can put the answer in your own required units. Normally, they are mentioned in millimeters. So basically, our total settlement of the foundation is 172 millimeters. Now, if we want to convert, because a consolidation is basically the movement or expulsion of water due to addition of load. So if we consider the 3D movement of water, that due to applied load, water will move vertically downward, rightward, and in the direction 90-degree in the direction of this page, uh, into the page or out of the page. So simply this will move in X direction, Y direction, and Z direction. To counter these 3D impacts, we will convert this 1D consolidation into 3D consolidation by multiplying it with a factor that is known as Skempton Jury, Skempton Jerem factor. So this mu is known as the Skempton Jerem factor. So normally this factor is taken as zero point 0.7. To convert this 1D stress or consolidation settlement into 3D consolidation settlement, we will multiply the 1D settlement with this zero point 0.7. So it will be nearly equal to 121 millimeters. So in three dimensions, in all the direction, the settlement will be 121 millimeters. There will be reduction because water is not moving only in vertical direction. It will move in horizontal direction as well. It will move in perpendicular to this page, perpendicular to your screen, and out of your screen or inside of your screen, mean perpendicular line to your screen area. It will move in this direction as well because soil is a 3D structure or 3D profile. So thank you very much. I hope you have understood. Uh, for the calculation of stress, we can divide these layers. For the calculation of absolute or correct or accurate or more precise consolidation, we can convert these soils into multiple layers. Mean you can convert them into smaller layers, and at the midpoint of each layer you will calculate the vertical effective stress and induced stress. Then you will revise the same procedure and you will apply different formulae as per the conditions of uh, first case, normally consolidated or over consolidated case 1, case 2, and then you will add, if you have converted 10 layers, then you will add the results of these 10 layers, SC3 up to so on SC10. Then you will get the total consolidation settlement. That will be near to 172 millimeters, but that will be more precise. It means if you want to get the precise and more accurate results for the consolidation settlement, so you have to divide your clay layer into more smaller layers. As much smaller layer as you can convert, you will get the better results. Thank you very much. See you in the next video.